So I don't know whether it's a good idea or not, but I like to experiment in public with new technology. So there's, up at the very top of the slide there, if you want to float a question to me during the presentation, just go ahead and on your phone or computer, just submit a question there, and I'll see it on my end. We'll try this out. Either it's going to be successful, or my presentation is going to just crash and burn, and then I'll have to do extemporaneous speaking for the next 30 minutes. So as Admir said, I'm Dan Timpson. I'm with DigiCert, Chief Technology Officer there. My main focus is working with our technical teams and running a publicly trusted CA. It's pretty interesting work. I would say it's very satisfying, it's very dynamic, and as Admir also mentioned, we're in the process of purchasing the website security business from Symantec, so we've really got our work cut out for us. Actually, before I begin, I want to just say that the speakers and the presentations have been really top-notch so far, whether it was the Agile Crypto, I didn't even have that on my radar, super interesting stuff. The IoT presentations, also hearing about all the really cool stuff from PrimeKey on the roadmap, from cloud to all the product enhancements with the appliance, some really good stuff happening, and I'm super glad to be connected here. So, in fact, when Admir called me and said, "Do you want to come to PrimeKey Days?" This was my reaction here. This is my 14-year-old daughter who loves to dance, and she'd probably kill me if I knew that I put this on the presentation. But yeah, I was like, going to PrimeKey Days, it's going to be cool, lots of neat stuff, new technology. So what I think I can add and bring to the table from the lens of a publicly trusted CA is what are the issues that users face in navigating the web public PKI. So I'm going to just throw up, okay, there's a website. It's Twitter. You guys probably all use Twitter, at least following PrimeKey and the hashtag PK Tech Days. But if we take a closer look, so what do we see in this bar? We see a green bar that's got the brand, Twitter Inc. We also see a location in the US, and then we see a scheme and the actual URL. I'm always in this dilemma when someone says, well, what do you do for work? And they're not a techno person at all. I vacillate between, do I tell them I'm a dolphin trainer? Do I want to get into the whole PKI discussion? So I'll usually start off with, there's that little lock when you're shopping on Amazon, and the connection is secured by a digital certificate, and it's what keeps you safe when you're doing your online transactions. So at the very least, there's an expectation that that happens online. Well, let's look at this next example here. So here's Facebook, and right off the bat, we see what? Well, the brand isn't there, and that's because this is a wildcard certificate, and there is not an EV standard for wildcards. The EV standard isn't allowed. And so one key nuance difference here is that this one says secure, whereas the other one didn't. So is this one more secure than the other one? Or all of a sudden now the user is maybe faced with some decisions on, okay, I'm not sure what this means. So there is an expectation of a fast page load, that the website identity is accurate, that the information exchange is confidential. And the users have to navigate all of this in the browser. So let's look at another example. We got two PayPal sites here. So we talked about the Twitter certificate with the location, so you can see that first one. Would you say that these sites are both safe to go to when you look at both the URLs there? Okay, so I'm seeing some shaking yes, some shaking no. So how about now? So, you see the problem is the indicators in the browser, the second one, the one below, is a phishing site. They'll be happy to take your information, and they'll be happy to take that information securely, in fact. But wait, there's more. So this is a site that I run. I'm a Roger Federer fan. I like to play tennis, and I've got just this website that's been out there for ages. And it's HTTP. So, heaven forbid I'd go to an HTTP site these days because we're an encrypted web after all, and that's the push for everyone. But even still, Chrome and other browsers are going to treat this experience differently too. So if I put a form on my site where I'm going to process information from you, that's unsafe. You might decide to give me your credit card or some national ID or something like that. So now we've got to worry about this. So really quick, in case you didn't know, I know this audience is pretty experienced with PKI. We'll go to PKI certificate school for just a minute. So DV certificates, all you have to do is prove that you own the domain. Right? This is why they're so successful with phishers. I don't have to do much to get that certificate. All I have to do is prove domain control, and that's it. All it really offers is session, security, and privacy. An OV certificate is the first one that you can actually have your brand as one of the attributes in the certificate, and that might be important for your brand reputation. And if you actually get into looking at the certificates, then you can actually see it. But on the outset, like we saw with the Facebook certificate, it's not really obvious. It just says secure, similar to the DV one. And then there's the Evy certificate, where this is the most stringent vetting. You get the green bar. Some of the browsers are more prominent in how they explain and show that bar than others. So, all right. Many of you guys in this room are nerdy enough to click into the certificate and actually start looking at it. And there's even a varied experience within the different browsers that way. So you can go in and see, all right, it's Twitter. It looks like it's a secure connection. OK, I think I can click on this side, and we'll go for it. And then, some of you will even take it a step further. The real hardcore crypto nerds are going to be like, well, what's the hashing algorithm, and what's the the ciphers, and what are the issuers, and all the subject SANs and all that kind of stuff. But general users, they'd be completely lost in here. So you have all of these ways that users interact with the software, and it's even more interesting when you think about public clouds and outages. So what happens when, these past couple of years we've seen Amazon, for instance, their whole infrastructure go down in a particular geo because of the fat finger effect. Some DevOps engineer pushed the wrong code, expired the certificates, and that was it. We've seen the same thing with Azure Cloud, an expired certificate, highly available public cloud, and it's just not working anymore. But it's good for users, right? The minute those certificates expire, you get something like this. You're on a public site, and you're like, wait a minute, I was just on Amazon, and what's going on? How many of you would click through that? We saw in the, okay, yeah, so you're used to Firefox, like when Alex and Harry were doing the demo yesterday. They're creating the EJBCA instance, and they're like, hey, add an exception to Firefox, accept the risk, go to this dangerous site. I want to download the malware. I want it. Damn it. I'm going to send it to all my friends. That's what happens. In this case, it was EJBCA, so we give you a free pass. It's all good. So this ties back to, where does all this trust really lie? So we talk about roots of trust and the root store. As Admir already alluded to, there are many in this list. This list is dwindling because the browser requirements are only going up. They're becoming more complex to navigate. They're becoming more of a headache to manage. And so this list is dwindling. If you can't abide by the rules, then we want you out, because this is one of the ways that we can enforce publicly trusted web PKI. I highlighted all the DigiCert roots there, by the way. We'll be using those. So I'm not going to get too much into this, because I think the other presentations covered this really well, especially like the Siemens presentation and whatnot. But web PKI is one, it's like what we're concerned about with DigiCert. But when we start examining all the other contexts, medical devices, publicly trusted clouds, private clouds, everything in between, IoT gateways, connectors, all this kind of stuff, the context in which you need to signal user behavior or signal whether a PKI is safe to trust or not becomes inordinately more complex. And it's a huge challenge. So We've got scalability to think about. We have to somehow keep the nefarious parties at bay. We see a real difference in how certificate management is done across the board. Thankfully, we've got good companies like PrimeKey that help companies manage that. And of course, there's a ton of variation in the browsers, and the fact that things weren't really designed for connectivity early on is a requirement. One of the ways that we can work on these is through embracing standards and rallying around standards and doing it. But standards in and of themselves are pretty interesting, and we all know how standards go. So the situation, there's 14 standards. Ridiculous. We need to develop one universal standard that covers everyone's use cases. Yeah. All right, now we've got 15 standards. And at least we've solved the charging one, right? It's like, is it mini USB or micro USB? What the hell? I don't know. Maybe it's not. So consensus is hard. Getting consensus. And struck by the problem with Agile crypto, for instance, in that you have to make a social movement as well as a technological movement to tell the story and get people on board and get it to happen. So I'm just going to give you a quick quiz, see if you guys have been listening. I know boat ride was good. People had fun. But let's see. Do you guys remember what CAA record checking actually stands for? So is it I put this in for Scott Ray. It's not the Chiropractic Association of Australia, or for the Swedes in the room, the Computer Application and Quantitative Methods in Archaeology. No, so it's Certificate Authority Authorization. So this essentially, and there was a little bit of reference to it yesterday, what it allows you to do is say what certificate authorities you're going to allow to issue certificates for your domains, what you control. And you can forbid all the others. Now, there is a caveat, because with any new technology that becomes standardized and adopted, people can decide, well, I'm not going to use it. And so you could still have a rogue CA that says, well, I'm going to issue a certificate for PrimeKey, and anyway, I'm just going to do it. But eventually, that technology won't really, or the people that are trying to do that, once the standard is more widely adopted, it's not going to happen very well. So let's take a look at what it means to do this. So it's pretty simple. I actually did do a quick little lookup on primekey.se, and there isn't a CA record, but if we were to configure it, this is what it looks like. First, you got to choose a compatible DNS stack, which that's a little bit of a problem in and of itself, because the DNS stacks are adopting the capability, but not all of them do it perfectly, and not all of them have the capability. So that's your first obstacle. And if you're in the cloud, for instance, and you're going to do some kind of cloud-based PKI, looking at CDNs like Cloudflare and others, they have it in beta. You can turn it on with their site if you contact support. So it's going to vary across the board, whether it's a hosted service or your own. But down the right-hand side, you can see we've allowed DigiCert and Quo Vadis Global, Symantec, some others to issue certificates for PrimeKey. So we would check first and then issue that certificate. There's also a mail to link for an abuse. If someone's doing something fishy, they can figure out where to send that to, and that could be triaged by PrimeKey. And then there's this issue wild, which would allow us to issue a wildcard certificate for primekey.se. So that's what it looks like. What's crazy is that this just went into effect September 8th. So all of the CAs are figuring it out. We're going through testing. We've got the security researchers kicking the tires on our site saying, are you doing it right? There's some DNSSEC complexity to that. And then one question that we get a lot is there any added issuance time when you add a CA record? Yes, there is. We're seeing about 200 milliseconds roughly to add a CAA check. And it becomes more complex if you are issuing wildcards, for instance, because then you've got to do a CAA check on each of those SANs in the certificate. Some CAs we're seeing will take as big of a hit as up to like 10 seconds per issuance. So it is something to be mindful of. One pro tip I would suggest is putting that CDN or putting the CAA record at your FQDN level, and then that way for your whole domain, it'll be easier to check rather than a bunch of subdomains. So this is, like I said, it's a new standard. But when we talk about CAA in its final form, there's some really cool stuff we can do. So for instance, coming back to the PrimeKey CAA record example, in the future, you'll be able to say, I only want to allow certificates to be issued from this account. So you can have an account parameter that you could put in there. You could specify a domain validation method parameter. I'm only going to do like DNS-based domain, Evy certs for my domain with this account. So essentially what you're doing is, in the ecosystem, we're giving power to the domain owner and user by letting them customize a policy that's kind of outward-facing in. Does that make sense? And speaking of the domain validation methods, this is another standard. It's crazy, but this was just standardized in the CAB forum and is now part of the baseline requirements as of July 2017. Here you see the various 10 methods. Before this point in time, it seems ridiculous to say, but all the CAs pretty much had their own method. If I wanted to do DNS check this way and Quo Vadis wanted to do it a different way, that's what the scenario was. But now, we've got a common set of standards across the way. So this is really Scott Ray mentioned, technology, process, and people. This is really the process component. We've all agreed with the browsers what these validation methods are. And if you don't use the method just as they're prescribed, that's considered a misissuance, and we have to show an audit trail and everything else to how this works. So it's actually a really good thing. It's a good development. We're happy to see it come through. Okay, there's been some really good stuff happening in the certificate transparency space. And just a quick refresher on this, certificate transparency is just a way for anyone to independently verify, almost real time, that certificates were issued by a CA for a particular identity. And what's cool about this is that it just brings transparency to the whole issuance process. There is a downside because the minutia, especially in the security research circles, everyone is super curious to be like, hey, look at this bad CA, they put some metadata in the OU field. Bad CA, we shouldn't do that, it's against the baseline requirements. So there's a balance between determining a material security risk versus we didn't obey a strict rule per se. But we're headed in the right direction with this. We've been one of the older log operators and participated in the Google project for this. And there's it's a good thing for the ecosystem as a whole. Oh, by the way, it's going to be mandatory in Chrome starting in March of 2018. So if you care about trust in the Chrome browser, every certificate you issue that's a publicly trusted cert will need to be logged to a CT log. And there's a minimum of 2. You have to go to 2 different ones, log those. In fact, okay, so I know Magnus was all saying, the nice thing about this crowd is that they're really technical and they like to nerd out on stuff. And so I'm going to show you this. So inside Chrome, this is probably not your average user, but there's something called net internals. You can go and inspect sockets, and you can pull down the raw SCTs, or the signed certificate timestamps that are embedded in the certificate. So in this case, I'm looking at PrimeKey. You want to stage all this before you actually load the website, then load it. You can see I've got an active socket to PrimeKey, and then the lower red box shows the actual SCT as well as the certificates. And what this really means is it's attesting to the fact that yes, a CA issued a certificate for PrimeKey.se. It's verified by the log. Here's the entity that did it. It's for real. Like, this is a good thing. It's a completely auditable history. So it's a playground for the technical, but if you ever want to do it, that's how you do it. So we've talked about standards that we've recently passed. Let me just talk for a minute about future looking. So we've had this idea, we lobbied it with the CAB forum about short-lived certificates. And the idea here is, let's say what we're trying to do is just narrow the attack surface, keeping the user in mind. Revocation is as much of a concern because we wouldn't need to do revocation because it's a small window. A good example of this would be .onion certificates. So think, people in parts of the world that they wouldn't want their governments spying on them or doing nasty things. If it gets the certificate or the service gets compromised, they could take advantage of that person. So having this small window would be a really good thing. This proposal didn't pass. People didn't see eye to eye. Again, consensus is hard. So we'll have to reformulate and figure out what we want to do. But these kinds of things in the web PKI community are discussed a lot and can be really good. And it's fun when you work on like CAA. I was talking about CAA probably 4 years ago, and so it's nice to see it come to fruition and actually be accepted and start to be implemented. Let's see here. Okay. So coming back to this idea of user confusion, we've got all these different browsers, we've got slightly different indicators, and each one handles it differently. Most phishing sites that are out there are taking advantage of the fact that there's this browser confusion. And so we can definitely tighten things up by bringing a more consistent signaling approach within the browser. There's good ways and bad ways of doing the various stages of validation. And so what we want to do is kind of clean up this mess. I mean, it doesn't look like much, but we've talked about this throughout these PrimeKey Tech Days. There's a balance between the usability of the system and the security of the system. And the example I always like to use is PGP. If I want to send Tomas G an encrypted email with PGP, we'll get to the point where I'm like, hey, Tomas, I didn't get that last one. Can you send it to me in plain text? Why? Because it's like hard to use, and it's difficult, and the masses don't really understand. So there's a balance between how we do this. I think this is a Swedish signal. At least that was my point here. We want to have a real consistent way. I mean, you probably wouldn't speed through a red light unless you're really looking for trouble. And likewise, we want to create the right kind of incentives for users in the web PKI to do the things that they need to do and really see where the problems are. So addressing these technical challenges below, as a certificate authority, one of the things that our mantra is really, what's the whole life cycle? How can we take that part and make it less complex so that businesses run, users are happy, and you've got a thriving web. So this is just kind of a summary of the things we've been talking about. And of course, the approach that we've tried to take as a company is having transparency, good collaboration with the community, and starting to think more about how we branch out from the web PKI into other communities such as IoT. So it looks like okay, I've got one more. So I've gotten a few questions from folks about what the post-close DigiCert means, and since we aren't closed yet, I'm limited on what I can say. But what we're trying to do, again, is just bring this lens of good community best practices and transparency and cleaning up the roots that have had problems. When we actually bought the Verizon business a couple of years ago, their SSL business, and we've done something similar, helping the sub-CAs come into compliance and encourage the right kind of practices along the way. We'll be doing the same thing with the semantic roots. There's a lot of question about the root program and which customers have pinned particular intermediates. So we're thinking about all the ways that we can have the best ubiquity and also follow in line with the Google requirements to deprecate trust in those semantic roots. So that's what we're really laser focused on, and we'll be able to say more once that's all closed. But that's that. So I think that's what I had, and somebody actually did get brave and use the audience. Let's see how this actually works here. I think I can present. Okay, so the first one. Okay, you can see the question. So even in the audience of PKI professionals, there were people who saw no difference between a site with Evy Cert and a site with a non-Evy Cert. Given this, how can we say that Evy Certs are any form of solution to make the internet more secure for regular people who are not familiar with PKI? Great question. There's a real philosophical debate. So right now, if you analyze all the data of phishing sites, PayPal is just ripe for phishing sites. They had something like 30,000 bad certificates issued for what looked like PayPal variant domains. But what's interesting with Evy certificates is there haven't been any, actually I take that back. There's one done by a security researcher, one malware or bad site instance of an Evy certificate that was a phishing site. So if we're just kind of looking at the law of big numbers, Evy is much better. You have a much better way or a much better assurance of knowing that you're dealing with the real entity that site is portraying itself as. And if we can encourage and coax the browsers to come along with us, we can do a lot more with the CAA checks and the validation methods and having indicators to show. I mean, you could show something in the browser that was a more intuitive interface to say, look, here's what was done, and kind of equate that. I'm not sure what that would look like, but certainly possible. Next question here is, how does a user use CAA to check Assert? What you could do, in the presentation, there's a tool that I referenced from SSL Mate. What that will do is at least go and show you that the domain that you were issuing a cert for had a CAA record. The user itself, I still think there's ground to cover as far as like what the user benefit is. So it's more about improving the issuance process than necessarily something right there for the user. But again, this could be a case where an indicator in the browser showed, hey, this domain was checked with, good processes were followed, and that was also augmented with the CT log information. Okay. So the next question is, how many CT log servers are there and who runs and verifies them? Oh, man. So there's a bunch. There's a program that Google runs. So Google's in charge. Ryan Hurst, previous CTO at Global Sign, is the one running the program. So he is a real PKI guy. And there's several. I've lost count. But you'll see you'll see CAs run the logs. You'll see independent security researchers. I thought that Verify had a log. If Verify's in the room, they could probably confirm. Okay, he's saying yep. So there's a number of community-driven logs, and the whole idea here was that the community would rally around and push up a log. The way it works is that you put your log up, and then you give your URI to Google, and then they test it for a time, and then you're accepted into a version of Chrome if you meet all of the baseline tests. And it is demanding. I mean, we've seen, I don't know how it's been for Verify, but we've seen that Google tests us on a regular basis. The real challenge in it is that you've got, it's basically a blockchain for certificates is the way to think of it. And so if you're in different regions of the world and you ask the CT log server, you need to get the same response, the same signed tree head, and the same response everywhere you go. And if you don't live up to the standard that Google wants you to do this by, then you get yanked. And so it's a constant thing to maintain. Okay, next one. This is cool. Love it when technology works. Okay, so Chrome has moved to hiding cert details behind an advanced view. Will the other browsers follow suit, and how will this impact users' understanding of the cert world? Yeah, those turkeys, I don't know why they did that. I don't think so. In the latest version of Chrome, they've actually brought it back, and if you open up the Chrome flags, there's now an advanced feature that says put the certificate link back. And so if you're interested in that, come talk to me offline and I can show you on my computer. I actually have it turned on because that just seemed really silly. I didn't buy any of the logic behind that. People are starting to recognize there's a lock in the URL. They want to see what's behind it. So why not improve that experience? It seems kind of wonky. Okay. From Florian, devices in LANs have configurable host names. Thus, they can't be manufactured with a valid cert. Are there any ideas to bring HTTP to these things? So, yeah, great question. So we actually have done some stuff with Cisco in this realm and Meraki, where the devices at provision time actually get a production cert. So the very first time you log in, so the problem that we saw with even Alex and Harry's presentation, the very first time you log into a production device, you can have a publicly trusted cert on that. So you think printers or any kind of firmware that runs an HTTP server, that can actually be embedded. The host name thing, I guess it depends on whether, what your provisioning process looks like. If it never has a host name, then yeah, that could be a problem. But it is possible to put public trust and embed those on devices. Okay. So why does CAA use domain names? Does this mean that the CAA always includes their domain name in the certificate? In what field? So let's see. So really, I think the reason why it's using the domain names is it's an extension to DNS, and that's really the crux of it. And no, the CA probably doesn't always include their domain name in the certificate. Well, actually, let me take that back. It depends on whether we're talking private or public trust. Like we always see, because of our root chain with a DigiCert intermediate, we have DigiCert in the name. It changed to DigiCert root, and so it's always there. It's part of the offline roots and the whole hierarchy of the PKI, so it's always going to be there. But that could vary depending on what your PKI hierarchy looks like. So that's it from the online questions. Other questions in the room? Oh, someone asked about, there was a topic yesterday on key generation within the browsers. So DigiCert is working with the community to come up with a replacement, and we're in the early stages of some beta that we're doing along those lines. This is another opportunity where if we can agree on a standard approach for how we could solve the key generation problem in a secure way for end users, love to link up with you and talk to you about that. So I'll just open it up to the room if you've got other questions. Or we take care of everything online? The technology just worked. One here, Tomas.
So how about the app ecosystem where there are no indicators? Is there any type of discussion around that?
Yeah, that's a great question. So I think there's similar initiatives with Evy Code Signing. So you have regular code signing, you have Evy Code Signing, and it ultimately comes down to the hardware and software requirements and the assurance that you have in that signing process. So I don't think that one's as far along, really, when you think about the landscape of applications. It's ripe for innovation and opportunity to do that better. Because you're right, it depends on the operating system. What happens in Windows with Smart Screen isn't the same as what would occur on Linux or Mac, and so getting that consistency is a problem.
And just to be more specific, I think the idea though is that there's no user interface on a mobile app.
Right.
So on Android or iOS, I start at bankofamerica.com or Handelsbanken or Nordea, and I have no indication of those apps actually. If I've got a secure channel, channel, and we've seen before, man-in-the-middle attacks happen or poor choices by certain mobile apps.
Right.
Will not use HTTPS, so there's no blanket like there is a padlock.
Yeah.
In a desktop browser.
Yeah, you're right. I mean, that strikes me too. So I know recently the Google Play Store, for instance, put malware scanning, really as a service on the devices. This is a recent with Android Oreo. I don't know if any of you have seen that, but I think that's the way you have to attack it. Is you have to look at the service part of it, and then also what's happening on the actual platform, and tie the two together. Because I'm going to be publishing online my applications and getting them signed and added into a repository somewhere. So there's a security processing component there that needs to be considered. And then to your point, what does it even look like on the individual OS? I mean, it's not very good. I mean, this is why we have so many problems with malware on mobile. Okay, well, unless there's no other questions, I'll turn it back over to you, Admir.